Imagine this. It's 45 degrees Fahrenheit outside. The air feels heavy, almost suffocating. The sun is blazing down, like it's trying to melt everything in sight. Now imagine yourself walking into a building, and suddenly, it's cool, not freezing, not artificial, just naturally comfortable. No loud air conditioners, no massive electricity bills, just silence and cool air. Now, here's the part that sounds almost unbelievable. This building has no air conditioning system at all. No compressor. No vents blasting cold air. No modern cooling technology. So, how is it possible? The answer is surprisingly simple. And at the same time, incredibly powerful. It's hidden inside the walls. Walls that don't just separate spaces, but actually store coolness. And what's even more fascinating is that this idea isn't new. It's not futuristic. It's not experimental. In fact, it's over 3,000 years old. Let's start with a real-world example. There's a building in California, located in a region where summers can get brutally hot. Normally, a space like this would rely heavily on air conditioning, running all day, consuming massive amounts of electricity. But this building does something completely different. It stays cool without using any traditional AC system. So what's the secret? The answer lies inside its walls. Hidden within the structure are large water-filled tanks, carefully integrated into the design. At first glance, they don't look like anything special. But these tanks are doing something incredibly important. They're acting as thermal storage systems. Here's how it works. Water has a unique property. It can absorb and store heat much more effectively than most building materials. So during the day, when the sun is heating up the building, instead of that heat immediately raising the indoor temperature, the water inside these walls absorbs it. Think of it like a sponge. But instead of soaking up water, it's soaking up heat. And it does this quietly, constantly, without any mechanical parts. No noise, no energy consumption, just pure physics. Now, you might be wondering, why water? Why not concrete, or brick, or steel? The answer comes down to something called thermal capacity. Water can store a huge amount of heat energy. Without changing its temperature very quickly. compared to materials like concrete or metal. Water is far more stable when exposed to heat. Let's make this simple. Imagine you leave a metal object and a bottle of water out in the sun. After a short time, the metal becomes extremely hot to the touch. But the water, it heats up much more slowly. That's because water absorbs heat gradually and releases it slowly as well. This creates a kind of natural balance. During the hottest part of the day, the water is absorbing excess heat, preventing the indoor space from overheating. Then later, as temperatures drop, that stored heat is slowly released, keeping the temperature stable. So, instead of sharp temperature spikes, you get a smooth, comfortable indoor climate, all without any machines. Now, let's bring this into a more human perspective. Imagine a family living in a region where summers are intense. Electricity costs are rising, and running an air conditioner all day isn't always practical. Every month, the energy bills keep climbing, and during power outages, the heat becomes unbearable. Now imagine that same home. Built with a system like this: thick walls, water integrated into the structure, designed to naturally regulate temperature. During the day, the house stays cooler, even without AC. At night, the temperature remains stable instead of dropping too fast or rising too quickly. It's not just about comfort, it's about independence. Less reliance on electricity, less stress about bills, and a living environment that works with nature, not against it. What's even more fascinating is that this idea isn't new at all. Thousands of years ago, ancient Persian civilizations were already using similar concepts. In extremely hot desert climates, they developed advanced cooling systems without electricity, without modern tools. One of the most impressive examples is something called wind catchers. Tall structures designed to capture airflow and direct it down into buildings. But that's not all. They also used underground water channels, known as canals. These systems brought cool water from underground sources, helping to lower temperatures naturally. Combined with thick walls and smart design, these buildings stayed remarkably cool, even in extreme heat. No machines, no technology as we know it today, just intelligent design and a deep understanding of nature. So here's the big question. If this works so well, why don't we see it everywhere today? Modern buildings are designed differently. They rely heavily on quick solutions, like air conditioning. It's fast, it's convenient, but it comes at a cost. High energy consumption, environmental impact, and complete dependence on electricity. Traditional systems, on the other hand, were built for long-term sustainability. They didn't fight the environment. They adapted to it. And maybe that's something we need to rethink. Because the future of cooling might not be about more powerful machines or smarter technology, but about rediscovering ideas that have been around for thousands of years. Simple ideas, effective ideas, ideas that work quietly in the background without harming the planet. So the next time you feel the heat and reach for the remote, just remember, there was a time when buildings didn't need machines to stay cool. And maybe that time is worth bringing back. But behind all of this, there is a simple scientific truth. Cooling doesn't always require energy consumption. It can happen naturally if conditions are designed correctly. Heat always moves from hot to cold. This is not technology. This is physics. So when a building uses thick walls, those walls slow down heat transfer. When it uses water, that water absorbs excess thermal energy. And when air is allowed to move naturally, it carries heat away without any machines. Together, these elements create a system that balances itself. No switches, no compressors, just controlled interaction between heat, mass, and time. This is not modern engineering in the traditional sense. It is environmental engineering. Now imagine applying these same principles today in modern cities with modern materials and modern architecture. Instead of relying only on air conditioners, Buildings could be designed to reduce heat before it enters. Walls that store thermal energy. Facades that control sunlight. Water systems that naturally regulate temperature. This is not about going backward. It's about combining old intelligence with new innovation. Because sustainability doesn't always mean invention. Sometimes it means observation. And maybe the future of cooling is already written in the past. And when you look at it closely, this isn't really a story about buildings. It's a story about choices. We built a world that depends heavily on machines, on constant consumption. But somewhere along the way, we moved away from solutions that were already working. Solutions that didn't demand more power, but worked with nature instead. Cooling was never meant to be this complicated. It was once quiet and deeply intelligent. So maybe the question isn't how far we can push technology, but how wisely we can design what already exists. Because progress doesn't always mean adding more. And maybe the future was never lost. It was just waiting to be understood again.